I'm Anil Kumar sharing with you some trigonometric equations which have two ratios involved. The strategy here is to square both sides and then solve the equation. The equation is cosecant x equals to square root 3 minus cotangent x, where x is between 0 to 2 pi. Now, as we did in previous example, we have cosecant x equals to square root 3 minus cot x. We'll square both sides. Remember, whenever you square both sides, you add error, right? So we will square both sides. Now this will incorporate also errors. So then that means you need to check for errors, right? So you need to check for errors when you write down the answer. So that's a caution. So when you square both sides, you get cosecant square x equals to square root 3 minus cotangent x whole square. So we can write this as, you know, the Pythagorean identity, which is 1 plus cot square x equals to cosecant square x, right? So we'll use this identity, replacing cosecant square x by 1 plus cotangent square x. We'll write this as 1 plus cot square x. And on the right side, when we square, we get 3 minus 2 square root 3 cot x plus cotangent square x. Now we can bring all the terms to one side, and then what do we get? Well, cot square x cancels out. So we are left with 3 and 1. So we'll take 1 on this side. So let's solve. So we'll bring 2 square root 3 cotangent x on the left. We get 2 square root 3 cot x equals to 3 minus 1, correct? So basically what we did was we cancelled cot square x and cot square x, brought this on the left side, 1 to the right side. So that gives us cotangent x equals to, this is 2, right? So it gives us 2 over 2 square root 3, or is equals to 1 over square root 3. Now cot is 1 over square root 3. That gives us possibility of two solutions within 0 to 2 pi, because cot could be positive in quadrant 1 or in quadrant 3, correct? So when is cotangent 1 over square root 3? We can take help of special triangles to find the answer. So what we know here is, in this special triangle 1, 2 square root 3, cot is reciprocal of tan, that means adjacent over hypotenuse, so that is pi by 3, right? So that gives us the value of cotangent, right? So it's 1 over square root 3. So therefore the acute angle for us is pi by 3, so this is pi by 3, and the other angle will be so this is pi by 3, so this will be pi plus pi by 3, that is 4 pi by 3, right? So that is the other solution, which is going to give us 1 over square root 3. Now these are two possible solutions. Let us check whether both of them are correct or not, right? So when we substitute, we know cot x is 1 over square root 3, so that we know. And what is cosecant x? So let us check for both the solutions. So let's check for pi by 3. So when x is pi by 3, then cosecant pi by 3 is equal to what? Cosecant is 1 over sine, right? So it is 2 over square root 3. So 2 over square root 3 is cosecant x. On the other hand, on the right side, we have square root 3 minus cot x, which is 1 over square root 3, right? So if you solve this, you get 3 minus 1 over square root 3, and that is equal to 2. So both match. That is perfectly fine. However, if you put 4 pi by 3, if you check for 4 pi by 3, then cosecant 4 pi by 3 in quadrant 3 is going to be negative 2 over square root 3, right? But on the right side, we will still get positive 2 over square root 3, which is not correct, right? So this is not correct. So therefore, we have only one correct answer. The other one is not correct, right? So now we can write down our solution. That is, the solution is x is equals to pi by 3 for the given example. So it is a must to check your solution when you square both sides, since squaring can cause error. For example, here it made it positive, right? So that is a caution whenever you do such questions. I hope that helps. Thank you and all the best.